今回のセッションは英語のセッションになりますので、ライブの翻訳の、アプリとか使ったらいいなと思います。よろしくお願いします。じゃあ、So hi everyone. First of all, I must say it was an honor to be here. And today I will talk about the basic and advanced techniques of native integration using Flutter. Before we go any further, please allow me to introduce myself. My name is Pigeon. I am system developer at Dreamers Company. As a part of my community activity, I am current an organizer for Flutter Seoul and GDG Grand Korea. So as you know, Flutter is an open source UI software development kit created by Google. We mostly refer to Flutter as a UI framework or UI toolkit. Additionally, everything is a widget. It can be used to develop multi-platform applications from the single code base that use the Dart language. As you can see in the figure, the Dart compiler can be categorized into native and web platforms. It supports a wide range of architectures built. When you're developing apps with Flutter, we often take advantage of different features from native platforms. For example, apps that require native platform functionalities such as sensor data, camera permission, and Bluetooth, and so on, and most important, implement these features in the native system. So recently, AI technology has been a hot topic worldwide. So we have made it possible to run large language models on smartphones. We primarily refer to this as on-device LLM. And there are several frameworks that enable the implementation of these technologies on smartphones. For Android, there is TensorFlow. And for iOS and macOS, there are options like MLKit and MLX. If you need to implement on-device LLM using Flutter, what should you do? Yeah. In simple terms, you will need to handle the inference natively and then process the results in Flutter. Here's the Flutter architectures. I think some of you might already know about this. At the bottom side, there's an embedded blocks that's implemented differently for each platforms. And there's platform channels and engine block. We communicate with the embedded through platform channels to use native features. Platform channels are really important for communication between native code and Flutter. They can be categorized in method channel and event channel. Method channels are all processed asynchronously. Additionally, they use codec functionalities to encode and decode messages between the native side and the Flutter framework. As you may be familiar, if you create the Flutter project, the main activity class in Android inherits from Flutter activity. To use method channel and event channel, you define the initialization and functionalities inside the configure Flutter engine method. In case of the Flutter plugin, you initialize the necessary functionalities and define the channels for communication with Flutter attached to engine method. So Flutter activity is an Android activity that displays Flutter applications, while Flutter plugins serve as an interface that handle communication between Flutter and the native platform, make it possible to add platform-specific features. So now let's talk about platform-specific code. There are many ways to implement interoperability, including Pigeons and FFI, which we will cover today. If you want to Flutter package it to work on different platforms, you will definitely meet this topic at some point. When you're developing Flutter plugin, there are a few key things you should keep in mind. There are many other points to consider, but I personally think it's really important to avoid supporting only one platform. When you're designing the plugin, it's helpful to keep the following checklist in mind. First, clearly define the requirements and features of the plugin. And next, design the data structure or data types needed for communication between native and Flutter. After that, write the platform-specific code and move on to developing the UI. This is a sample apps that I have implemented. It received the sensor data and battery information from the smartphone to enhance the UI. Let's go through this example following the design steps that we saw on the previous page. First, it's important to specify unique channel name for each features when creating platform channels. And therefore, it's a good idea to design the channel name for each function before starting the implementation. Additionally, it's important to decide whether the channel will use the method channel or an event channel for communication. When you implement this in code, you would write it like this. The channel name must be same in both the native and Flutter for receiving battery level and gyroscope sensor data. Next, we design the data types. I choose to receive the battery level information as an integer type, while the gyroscope sensor data is received as a list of double values. We'll explore how to implement a handler directory within the main activity to get battery level. Additionally, we will create a sensor program class that inherits from the Flutter plugin to handle sensor data. Here is an implementation code for method channel to retrieve battery level in the Android native code. We pass the binary messenger and channel names as parameters for the method channel. The dot executor runs the dot code is started with the main function and main dot part and keep going until the code finishes or the Flutter engine is destroyed. Inside the set method called handler, we need to define the code that will execute it when the get battery level method is invoked from Flutter using invoke method. The get battery level method retrieves the current device battery level information, but it obtained this information from the Android intent related to battery level. You can do success method of the result object and pass the battery level as a parameter. When this code is executed, it processed on the native side, it sent to the Flutter side. By using the error method of this object, if your error is encountered, you can send a message to Flutter. So the UI can handle the error and respond the right way. To receive sensor values, we developed it through the Flutter plugin. Sensor plugin is a class that implements the Flutter plugin interface. Like I mentioned before, when you implement the Flutter plugin, you override the onAttached-to-engine method in your class to use it. For gyroscope sensor values, we used an event channel as previous design. We set up the event channel by implementing a stream handler in the setStreamHandler method. This method is an interface that requires you to implement the details functionalities of the onListen and onCancel method. In the onListen method, the event parameters is an event sync object. This object is used to send data to the dark side. You can use event to transmit data to the Flutter app, just like with method channels. You can handle success and error cases. This Kotlin code defines the pre-built function named sensor event listener that returns the sensor event listener object. This is designed to monitor sensor events, process sensor data, and then send the processed data on event stream. When the sensor data changes, the own sensor changes method get called. So you can receive the new sensor values. We call the success method to the event sync while pressing the sensor values at the same time. It's simple. The implemented sensor program can be easily added in the configure Flutter engine method on the main activity class. This concludes the native implementations, and now let's take a look at how to implement it in Flutter. This code defined as an asynchronous method named getBatteryLevel in Flutter, which is used to receive battery level information. This line of code calls a native method asynchronously to fetch the device battery level and wait for an integer result using the method channel in Flutter. If you do not specify the generic type, the data type will be set the dynamic. If you want to handle data safety, you should define this type using generics. To receive sensor data in Flutter, you define the event channel with the channel name. And use the receive broadcast stream methods to fetch the data. This covers the fundamental concept for communication between Flutter and native code. The understanding of this part will make it much easier to write platform-specific code. Now I briefly introduce the platform-specific patterns. The first patterns refer to the pattern used when working with a separate program class. For method channel, Flutter call native functionality using invoke method. In the case of event channel, data is received from native code through receive broadcast stream. And both methods set up the handler and listener within configure Flutter engine method. The second patterns involve adding the program inside the configure program engine method of a Flutter activity. The third pattern involves developing separate program classes for each functionality without using method channel or event channel directly in configure Flutter engine, and then adding those program classes in configure Flutter engine. The fourth pattern involves developing and using program within a package folder under the project directory. This pattern can be managed using a monorepo approach within tools like Melos. Finally, we have a method of using plugin platform interface package. By using this package, you can implement multi-platform native functionalities within a single program. Alternatively, you can create separate packages for each platform to develop specific functionalities in detail. When developing a program, you need to specify the platform-specific details in YAML file. If you have implemented all the platform-specific features in the program, you can list them like the example on the right. If you're developing each platform-specific program, each packages, you should include the package names in the YAML file. For more detailed information, please refer to plugin platform interface package. When communicate between Flutter and native code, as an important aspect is type safety. Let's explore why type safety is important and how we can ensure it in our implementation. If the code that was previously exchanged data as a string is suddenly updated to use JSON format, you may encounter error during the typecasting in Flutter, resulting in the inability to receive the data. To solve these issues, we can either use protocol buffers or just make all the data in JSON format. Using protocol buffers helps keep the data consistent across platforms, which make things a lot easier and convenient. Next, what we can use is Pigeon. Pigeon is a code generation tool that facilitates type safe and easier and faster communication between Flutter and the host platform. It generated a boilerplate code needed for platform-specific implementations. It provides support for all mobile platforms as well as code generation for Windows, Mac OS, and Linux. For more detail, you can check the pub.dev or the GitHub repository. As you can see, Pigeon is a package that developed and maintained by the Flutter team. You might be familiar with these packages as they are commonly used in many applications. Yeah, all these packages utilize native functionalities and make use of Pigeon. As you may know, FlutterKaigi has been migrated to Pigeon since 2 years ago. Using Pigeon itself is not difficult. As shown in the picture, you can define your method and data types in Dart file named message Dart, and Pigeon will automatically generate the necessary code for each platform. You can name the file whatever you like. Today, we will explore the process of implementing encryption features using Pigeons to access native functionality. The implementation will involve defining messages, outlining the API, and then generating the code using Pigeon. After that, we will proceed with the details implementation of the defined method. First, to use Pigeon, you need to add it to the dev dependency sections on your post.yaml file. Then we'll define the message structure for handling encryption. We can also use enums in this process. Next, we define the method. We use the host API annotation and define them as an abstract class. As you can see, Pigeon does not provide the detailed interpretation for each method. It simply generates boilerplate code. And therefore, we need to write the code to implement the functionalities of each method ourselves. If asynchronously process is required, on the native side, you will use the async annotation. We can use host API and Flutter API annotation. And host API is used when you want to call native functionality from Flutter, whereas Flutter API annotation is used when you want to call Flutter app from the hosted platform. Once all the definitions are completed, we generate the code using Dart run Pigeon. The method you can see not involve generating the code through the CLI. The recommended approach now is define options by using the configure Pigeon notation inside definition file name message Dart file. By specifying the C++ option, boilerplate code will be generated for Windows platform development. And by setting the Kotlin and Java options, code will be generated for Android platforms. By using the Swift and Object-C option, you can generate code for iOS and macOS. The code generation process has become much simpler compared to previous method, right? When using Pigeon and plug-in platform interface package, the folder structure looks like this. You create separate package for each platform, and then apply Pigeon to generate the respective code for each platform. Implementing on the Flutter side is simple. As mentioned earlier, all platform communication code need to be handled asynchronously. You just need to instantiate the API and call the method, and that's it. You don't need to worry about any extra typecasting. And on the native side, you need to implement the method. The custom API implement class inherits from custom host API that's generated code by Pigeon. When using define the API, the decrypt method uses the async annotation. You can notice that the return type is reserved, which differentiates it from regular method. Using result allow for handle both success and failure cases, providing a structured way to manage different outcomes. Next, we instantiate the implemented class within the configure Flutter engine method. We use the setup method from custom host API to use the program. Without calling the setup method, you won't be able to invoke any method. Inside the setup method that set up the codecs, message channels, and handler configurations, and the result of the implementations are shown here. But it looks like the iOS part hasn't been implemented yet, and that's causing a preference section error. Let's quick fix this issue. For iOS, create the class that also inherit from custom host API and implement the detailed functionalities for each method. I use CryptoKit for the implementation. We also need to handle the setup method for iOS in the same way. This is necessary so that we can properly call the method from Flutter. Now, as you can see, the hash processing are working well, both Android and iOS. You can easily create your own packages without using any external packages. Next, Pigeon is useful for handle interaction with native languages, but sometimes you may need to access lower level languages such as C++ and C libraries. In this case, FFI has a big impact. Let's learn more about FFI. FFI stands for Ffigen Function Interface, and that's tools that enable interaction between Dart and C languages, especially when we need to optimize performance. It's super useful for directly calling native libraries. As I mentioned before, sometimes we really need to interact with C libraries. For example, when you're working with databases and image process or graphic text, you can use FFI direct call, native code, and library. This really helps with performance optimization and give you access to many features. Using FFI means doing a few steps, and that's all. Yeah, it's simple. If you make it your own libraries, you start by using CMake to create the dynamic library. Then you define the lookup functions with the Dart FFI package before you can call those functions to use them. Let's create the functions and a library that perform simple Fibonacci sequence operations. We'll define the functions that need to be implemented in the header file. I will implement the Fibonacci functions in the C file. As you can see, I will use a recursive approach to implement the Fibonacci sequence algorithm. Now we need to create and write a CMake list file to build a dynamic library. And use the dynamic libraries open method from the FFI package to load the library file you just built. The way you create libraries and the file names can be different for each platform. In the case, you can handle a branch for each platform like this. Define the lookup function using the following process. And this code loads the Fibonacci function from the shell library or dynamic library and convert it into the Dart function using lookups and S function. So it can be called like a regular Dart function. The parameters and return data types, so native functions must match exactly. In addition, Rust and Go languages support tools and builds of various architectures. You can create libraries using not only C, but also Rust and Go, and apply them to Flutter using FFI. Today, I will show you how to use FFI with the Rust language. To create a C dynamic library with Rust, you need to add the library to the TOML file. This is a Fibonacci sequence algorithm code implemented in Rust. To use it on Android, we build it for each architectures. The Rust they support build each architectures. So the generated results are shown right on the right. And Rust is using cargo. So you use the cargo build and generate each architecture files. And then press build library file into the Android folder of the Flutter project, organized by architectures, like this. And then loading a dynamic library file is the same as before. It's not difficult, right? There is a way to improve readability by using typedef. As you can see from the code, it's actually not difficult to use. It's just like that. It's a goal. And then there is also the ffigen packages, which can automatically create these lookup functions through code generation techniques. It conveniently handles the data type specification without any hassle. If you are using library like SQLite or OpenCV, I recommend using ffigen. First, to use ffigen, you need to add the dev dependency sessions of your Bobson YAML file. And we need to create an ffigen YAML file and provide a header file to use ffigen. The lookup functions will be generated based on function defined in the header file. Now we will generate the code. It's simple. By using the YAML file as the basis, and you can easily use ffigen to generate the code. So you can easily call functions from the native library classes. This makes things easier for the driver flow and helps them respond flexibility to any changes in the library. You no longer have to worry about how to create lookup functions or how to match data types. Yeah, to sum up the session, today we covered the basic to advanced techniques for implementing native features in Flutter. And we explored 5 patterns for platform-specific code and covered how to use method channel and event channel. We also look at reasoning for using pigeons and how to use it with implement encryption functions and hashy examples. And lastly, we learn how to use C and C++ libraries through FFI and ffigen. And if you have any questions, please feel free to reach out on GitHub or X. And thank you very much for coming to these presentations and for your attention. And thanks to all FlutterKaigi staffs for organizing such an amazing conference. Thank you.